I've done so many videos in the past 5 years about the Linux terminal, the command line, the various shells available on Linux, the various shell utilities available on Linux. I've got some playlists you could go check out if you want some more in-depth coverage on the individual shell utilities. But today I'm going to give you a whirlwind tour. We're going to learn the Linux terminal in 30 minutes. So I've opened up a terminal, and when you open a Linux terminal, it's going to always open in your user's home directory at first. You can see the tilde character here. The tilde character is an alias signifying we're in my user's home directory. I can verify this with the pwd command for print working directory. If I hit enter, you can see I'm in /home/dt. The tilde character is simply an alias for /home/dt. dt is the name of my user. If I want to see the contents of this directory, I can use the list command, which is the ls command, and it lists all files and directories in this current directory that we're in, my home directory. Well, it doesn't list them all. It only lists the ones that are not hidden. If you actually want to list all the files and directories, including the hidden ones, the ones that begin with a period or a dot, do ls-a. When you give it the A flag, now you get a list including all of the dot files. That's the hidden files, the ones that begin with a dot. If you want a long form listing, you could do -L. And if you want a long form listing including all the hidden files, you could do -LA. Let me hit Control-L to clear the screen. Control-L is a key binding. It's just an alias for the clear command, which works as well. The two most common commands that you're going to enter in a terminal are the ls command, which we've already seen, and the cd command. So if I wanted to change into, I don't know, do I have a test directory here? No, let's make one. Let's make dir test. So make directory, and I'll call this new directory test. Now let's change over to the test directory. So cd, change directory to test. Let me do a ls. It's an empty directory. If I cd back into home and do an ls, there's the contents of my home directory. And that's mostly what you do in the terminal. That's a large part of what you're doing is you're moving around the directory structure. You're doing a lot of cding, and then you're doing an ls to see what's in the new directory that you've gone to. Now, other than doing cd and then, the name of some directory, like, I could go to my downloads directory, I could also do cd and give it these aliases here. Cd space dash will take me to the last directory I was just in. If I up arrow to get that last command and do cd dash again, it takes me back to downloads. Cd dash now takes me back to home. You see how that works? I could also do cd space period period. Period period is an alias for the parent directory, meaning go up one directory. Right now I'm in /home/dt. If I cd ... it will take me into simply /home. If I do cd space dash, it takes me back to home. Or I could have done cd tilde character, which again is an alias for /home/dt. That would also take me home. Or cd without any argument always takes you home. If you want to learn more about a command, for example, the cd command, you could read the man page, the manual, right? So man space name of command. cd, for example, and you could read the manual for the cd command. There's not much to it. The cd command is pretty straightforward. Q to quit out of the man page. Also, most of your commands in Linux will have a -- help flag. So 2 dashes followed by the word help will give you a quick overview of the flags and options that are available for that particular command. One of the most common things you'll do in a terminal is you'll want to read a file, and you can open the file with a text editor. For example, if I just want to read what is in the contents of my .bashrc file, I could read it with nano. Let me quit out of that. I don't want to save. But a lot of times you're not wanting to make any edits. You just want to read a file. Well, you can use the cat command. So I could cat my .bashrc, and it actually just prints it out here as output in the terminal. Now, it's a very large file, so I would actually have to scroll back to actually read some of this. But what I could do is, instead of cat, I could use the less command. So I could less my bashrc, and it starts at the top, and then I just hit the space bar to go down each line and read it. When I'm done, hit Q to get out of the less. So let me cd into this test directory that I've created. If I do a ls, there's nothing in it. So let's create a file. How can you create a file? Well, if you just want to create a file without doing any kind of editing, you just want to create a file just to work with maybe at a later date, you can use the touch command. So I could touch file1.txt, for example. If I do an ls now, you can see there is one file in this directory called file01.txt. Now, if you want to edit it, you could nano file1.txt. If you want to use nano as your editor, but you could also use vim. Vim is typically on the system as well on most Linux operating systems. And if you open that in Vim, you can see there's nothing here. It's an empty document because we haven't added anything to it, but you could edit something and then eventually :WQ for write and quit to get out of Vim. Let's talk about copying files, moving files, and removing files. So to copy a file, cp is the copy command. So I could copy file01.txt to a new location. I'll copy it over to file02.txt. And now if I do an ls, you can see now I have two different files, file1 and file2. Now to move a file, you use mv for the move command. I'm going to move file2 over to file03.txt. And now when I do an ls, I'm going to have file1 and I'm going to have file3 because file2, I moved it. I essentially renamed it is what moving will do. And of course, I was copying and moving within the directory I'm in, but I could send these to anywhere. I could move file03, for example, over to my home directory. So let's do the tilde alias for /home/dt, and I'll move it to my downloads directory. Now when I ls, only file1 is in this test directory because file3 is now in my downloads directory. To remove a file, rm is the remove command, and now I'll remove file1, and there you go. I do an ls. Once again, we're at an empty directory. Now let me do the make dir command again. I'm going to make a subdirectory here. I'm going to call it test2. By ls, you can see test2 is within the test directory that we're currently in. I'm going to cd over into test2, and then what I'm going to do is I'm going to touch file1, file2, file3, file4, file5. If I do an ls, you can see we have, actually I mistyped, I added a space accidentally here, so actually I created file and then another file simply called 4, so actually I have 6 files here. Now let me cd ... so back to the parent directory, right? So ls, there is the test2 directory. How do you remove the test2 directory? Well, you can't actually use the remove command. The remove command is really for files. To remove a directory, you use rmdir, remove directory. But that only works if it's an empty directory because the shell wants you to go into test2 and individually remove all the files to make an empty directory and then remove the empty directory with rmdir. That's tedious. There is a command that will force it to just delete the test2 directory and all of its contents, and that is using the rm-r flag. That's recursive, meaning I'm going to delete whatever you give me plus everything inside that directory, all the subdirectories, all the files in the subdirectories, yada, yada, yada. This is a dangerous command, rm-r, because if you did this in the wrong directory, for example, your user's home directory, you would actually delete your entire home directory, all of your user data. So be careful with this command. But if I run that command, do an ls, you can see the test2 subdirectory and all the files that were in it are now gone. By the way, the recursive flag, that -r flag, that also works with copy. When you're copying a directory and subdirectories, you'll need the recursive flag with the copy command as well. One of the commands that you'll see me often enter on camera is the where is command. If I'm taking a look at a Linux distribution and I don't know if a particular program is installed, I'll do where is, all one word, space, name of program, right? So, if, for example, is Firefox installed on my system? I don't know. Let's do a where is Firefox. And if it's installed on the system, you'll get name of program : and then you'll either get nothing behind name of program : if it's not installed, or if it is installed, you'll get the location to the binary, the location to some libraries, maybe the location to a man page. Let me give you an example of a program I know is not installed, Zed, which is a text editor for, I believe, the Cinnamon desktop environment. I'm pretty sure I don't have it installed, and you'll see I get nothing returned, right? So Zed is not installed. Another similar command is the which command, which is a little simpler, right? Instead of giving me the location to libraries and man pages, it's just going to give me the location of a binary. If I did which Emacs, I'm just going to get the location of a binary for Emacs, where if I do a where is Emacs, I'm going to get much more information. Another command I often enter at the terminal is a uname command. Now, if I do uname without any arguments, it's just going to tell me Linux, the name of the kernel, right? But if I do a uname-r, it will actually tell me the actual kernel version. You can see on my machine right now, I'm using kernel version 6.1.15-1-LTS. Now, if I do a uname -a for all, it will give me everything that's part of the uname command. So I get the kernel, the distribution I'm on, the kernel version, yada yada yada. You see time and date, and the name of the operating system is GNU/Linux, etc. And of course, there's flags and options to get each and every one of these fields out of here. The most useful one that most Linux users are going to want is that uname-r, because often you want to know what kernel version you're on. Another common command that I use on my videos is the wc command, and typically I use wc --l for a line count. Wc is the word count program, but usually I want a line count for some things. For example, maybe I want to know how many lines are in my bash rc. Well, I could do a wc-l on my .bash rc, and I get no such file or directory. So that's because I am in the test directory. So what we need to do, cd no arguments, gets me back to home. Now if I up arrow twice, I go back to that command wc-l.bashrc, which now works, and you can see I have 294 lines in my .bashrc file. By the way, the .bashrc file in your home directory, that is the bash shell's config file. Another common command I use on Linux is the find command, where you do find and then the location of some directory. Maybe I want to search my downloads directory for some particular string, and I typically use this flag a lot, -i name, which is an insensitive name search, and then I'll give it a string to search for. For example, Linux. I probably have some Linux ISOs in my downloads directory. If I do a search for that, nothing came up. But let's search my entire system for something. So let's find on root, the root directory, which means search my entire file system, all, I don't know, hundreds of thousands of files on my system for -i name Linux. Now this is going to return a bunch of stuff. I don't want to sit here and wait on it to find all the files that contain the string Linux. So I'm going to do a Control-C to kill that command, right? Control-C will kill a running process. So that's how you terminate any command, any lengthy command that you want to get out of. One other thing I want to mention is I did find on root. I can also do find period. Find period. The period is an alias for this directory. So if I do -i name and I do bash, for example, you see I have a few files that contain the string bash in my home directory and in various subdirectories, because it does do a recursive search here. So let me Control-C to kill that. So period is your current directory. Period, two periods, remember, is the parent directory. The next command is the echo command. For example, maybe I want to echo hello world. And that's all that does, right? The next command is the printf command, which is similar to the echo command, except the difference is it takes a different kind of format. And by a different kind of format, I mean you actually specify a format with %s. %s is going to be some value that we'll give it later. And then maybe I want to do a \n for a new line. So print some string followed by a new line. What string? Well, how about hello world? Misspelled. All right, then there you go. And you can have more than one %s values here if I wanted to. I could add another one as well, and once again another new line. And let's go ahead and do a second something here. I don't know. And you can see hello world and then new line and then something. And there is a space here because there was actually a space after the new line break. So if I wanted to, I could up arrow. If I didn't really want that space there, I could get rid of the space, and now they're lined up as expected. One important concept with these Linux shells is the pipe symbol. The pipe symbol is you being able to take the output from one command and put it into the next command as input. For example, if I cat my .bashrc, that's the cat command. Now let me up arrow and then cat .bashrc pipe and then less. What it's going to do is it's going to take that cat output and then rerun it with the less command. And you can see how that works. Now I'm actually reading it as less. Now that command is kind of useless because I could have just done less.bashrc, but that's just an example of how you can string commands together with a pipe. Instead of less, maybe I want to take the top 10 lines, so I could do pipe head, and you can see I just get the first 10 lines. If I want to specify a number of lines, I could actually do -n, and maybe instead of 10 lines, I want just 5 lines. Or maybe instead of head, maybe I want tails. Maybe I want the tail, which is the last 5 lines in this case. Or maybe I want to do tail the last 10 lines, but of those last 10 lines, I really just want the first 5 of those last 10 lines. You can see you can just keep stringing these together with these pipes. I'm going to cd back into the test directory, and I'm going to clear the screen. Let's talk about redirection. So I'm going to echo hello world again. And this time, I'm going to do the right-pointing arrow, the right-pointing chevron, the greater than sign. So what this is a redirection. It's going to take that output from echo hello world, and it's going to send that to wherever I want to send this. In this case, I want to send it to the name of a file. I'll call it file1. If I do an ls, there is now a file1 in this test directory. If I do a cat on file1, you can see the contents of that file contain the string hello world. Now, let me up arrow, and I'm going to echo something different this time. So let's echo something different. And this time, instead of the 1 greater than sign, let's do 2 greater than signs. This is a redirection, but this appends the file. And so what this does, it takes this line and it adds it as the last line of the file. So let me hit enter once again. Let me up arrow cat file1, and now you can see hello world, and then the next line, something different. Now, if I up arrow, and instead of doing the append with the 2 greater than signs, if I only did a single 1, it actually overwrites the entire file with this string. So let me hit enter, up arrow, cat, and now the file simply reads something different. So 1 greater than sign actually writes the file, overwrites the entire file with whatever you're doing. The 2 greater than signs appends the file, meaning it adds it at the end of the file. One of the most powerful shell commands is the grep command. Now, the grep command is a search command. You give it a string, so I'm going to grep the string, how about Derek, which is my first name. And where do I want to search for this? We have to give it a file. Well, let's search my bashrc for the string Derek. It doesn't exist. But if I typed Derek with a capital D, there is a line in my bashrc that does contain my name, that string Derek. What if we wanted to search for every line in my .bashrc that didn't contain the string Derek? Well, let's do -v for inverse search, meaning give me every line but the line that contains that string. And you can see now it actually gives me basically my entire bashrc minus the 1 line. If you want to do a recursive search, you could do -r. So I'm going to grep -r, and I'm going to search for my first name. And then I'll just do the tilde character here, right? We're going to search the home directory, and we're going to find my name all over the place here. So I'm just going to go ahead, Control-C to kill that process. Let's go ahead and clear the screen. Another powerful shell utility is the sed command. Sed is typically used for substitutions, and it's usually done in this form, sed, and then inside single quotes, you want to do s/ and then some string / and then some other string /g. And this is the string you're searching for, and this is the string that is replacing it, right? So if I wanted to search for Derek and replace it with Bobby, right, on my .bashrc, now I'm going to have to scroll back up, but what we could do, since we know pipes now, let's just go ahead and make this easier to read, and let's pipe that into head-n5. And there's the first 5 lines of my bashrc, and where Derek Taylor used to be, now I'm known as Bobby Taylor. Well, not really. This is just output to the terminal. It didn't actually write that. It didn't overwrite my bashrc. If I wanted to make that permanent, I would have to give sed the -i flag, and now if I do that, let me vim my .bashrc, and you can see it actually did change that. Now I can change that back real quick, and let's do a :WQ to write and quit out of vim. Another command I love is the alk command, which has a number of different uses. I've done videos about awk in the past, very powerful command, but the most basic usage of awk is typically done with awk, and then inside single quotes, and then inside the curly braces, you do a print space $, and then the name of a field you want to print. Maybe the first field, for example. So let me show you this in action. So if I cat my /etc/passwd file, a standard file on the computer as far as Linux systems. This is a file that contains all of the users on the systems and their default shells, their default home directories, yada, yada, yada. And you can see there are colons that separate each of the fields. Well, if I do cat on /etc/passwd and I do awk and then the single quotes, swirly braces, print $1, it prints the first field, but by default, awk actually uses spaces as field separators. So in this case, because the file uses colons as field separators, I need to do -F for field separator and specify that the colon is actually the field separator, and then print the first column based on the colons. And now I get a list of usernames, because those are the actual usernames is the first column. If I wanted the second column, they're using the X server. The third column gives me, I guess, the user ID of each user. You can see how that works. Awk, very cool command. Another similar command to awk as far as being able to pull out fields and columns is the cut command. So I could do cut, and I could do -F1 for field 1 and -D for delimiter, and the delimiter is the field separator. They just call it a delimiter with cut. And then once again, I'll specify a colon, and I still get that list of users. So just a different way, awk or cut, both can pull out columns if you're dealing with a file where information is laid out with separated, like comma separated values or colon separated values. Awk and cut will be your best friend. A common command that I often run on my Linux distribution installations and first looks is the xrandr command. So if you're using the X server, what this does, it tells you all the displays that are currently connected. And I have 3 displays, 3 monitors currently connected. There's the names of the monitors. Now, through the magic of some of the commands we've already learned, plus piping, I could actually do something like xrandr and then pipe it into grep, and the lines that contain the monitors, I notice, contain the string connected. So let's just grep the word connected. Okay, that works, but I only want the monitor names. I don't want the entire line that contains the monitor names. So how would I get that information? Well, I could use awk if I wanted to use the awk method, and I could simply print $1. And that works, and by default it uses spaces as field separators, which is what I wanted, so I didn't have to specify a field separator. Or, once again, I could also use cut -F1 for field 1, -D for delimiter, and I do need to specify that we're using spaces with the cut command. And you can see, that is a very nice, tidy way to get a list of all of your monitors and monitor names. And I typically do use this kind of stuff when scripting, especially when working with tiling window managers, where sometimes in your configs you need to specify what your monitors are. Well, this will automatically get your monitor names for you. How cool is that? Let me cd into the test directory once again. Let me do an ls. I still have file 1 here. Let's talk about chmod. So change mode is essentially what this is. This changes file permissions. So if I chmod 755 on file 1, and I did a ls-l for long format, this string here of rwx's, this actually is the file permissions for that file. That's read, write, execute permissions. And 755 is pretty liberal as far as permissions. If I wanted something a little stricter, I could chmod 644 on file 1. If I do a ls-l, you can see now all those execute permissions that we had before, now nobody has execute permissions. So if it was a script, nobody could run it. I've done a video detailing in great detail file permissions on Linux, so check that video out if you're not familiar with that. Speaking of making scripts executable, oftentimes you'll do a chmod plus x, meaning plus executable. Basically, it adds all the x's to the file permission string. If I did file 1, now if I do ls-l, you can see we have 3 x's in the various places where the executable flag should be. If I wanted not to make that executable, let me up arrow and chmod -x and then up arrow ls-l. And you can see the x's are now gone from the permissions. Now ls-l gives you the owner and the group of the file as well. Now if I wanted to change the owner, the person that owns the file, you would chown, right? Change owner. And then typically you would do name, name, because often the owner and the group are the same. And then the file that you're going to change that to. If I hit enter, of course, there's no user on the system named name, right? So that command does not work, but that is how chown works. And of course, you could chown recursively. You typically will have to do that in directories. So recursively change everything in, some directory somewhere. And be careful when you chown recursively, because if you did that in the wrong directory, you could actually seriously damage your system. For example, if you chown everything in the root directory, that would really destroy your machine. So be careful when you're doing recursive chowning or chmodding for that matter with the file permissions. That's also very dangerous if you do that in a top level directory. Let's talk about the history command. So if you type history in the shell, you will get all the commands that you've entered, right? Gives you a nice little history of the commands you've entered in the shell. If you want a shorter history, you could do history and then give it a number. History 10 just gives me the last 10. One of the most common things you'll do with the history command is pipe it into grep, because you'll be searching for a past command, something you entered days, weeks, maybe months ago, but you forget the exact command because it's a lengthy command. Maybe that xrandr command that I did earlier. I don't remember what I piped it into. I don't remember all the flags and options. I just remembered it was an xrandr command, so let's grep for the string xrandr in my history, and it will give me all of those, past xrandr commands. Oh, there's the one I wanted. So that's how that works. You'll often do history into grep. Another thing with history, you notice that the commands have numbers, right? They're numbered. And if you want to run a command, for example, the clear command clears the screen. It's numbered 655. You could do bang, which is the exclamation point, bang, and then number, for example, 655. Watch what happens. It runs the command in our history that was numbered 655, which was the clear command. Bang, bang is interesting because it always runs the last command. So if I hit bang, bang, it just simply runs the clear command because that was the last command. For example, one of the most useful things to do on your system is to run an update. For example, on my archlinux system, I'm running archolinux actually, I could do a pacman -S lowercase yu. It says, error, I can't run this as root. Well, sudo bang bang, which bang bang means run the last command, except this time with sudo. And now it's actually going to ask me for my sudo password, and I can actually run the update. I'm going to control C to cancel that process. Speaking of processes, how do you kill a process at the command line? You can use the kill command. You would do kill and then, some kind of ID number. If you wanted the ID number, you could get it with the top command. I typically like a htop, so just a better top. But if you get the process ID, you could use the kill command to actually kill that process. Another thing you could do, if I switch to a different workspace, you could use the xkill command. So if you're killing a graphical program, xkill turns your cursor into a skull and crossbones, and the next window that you click on, it will kill that process. So if I click on this terminal, for example, it killed that terminal. Another command you could use is kill all, meaning kill every process that has this name. For example, kill all conky. If I make this window a little smaller, conky is the system monitor here. Kill all conky. Conky is gone. Let's go back to our original terminal, clear the screen. Some common networking stuff you'll use will be the ping command. For example, I could ping google.com and just let the ping run for a second. And you can see now it's pinging google.com very slowly, but it's coming. Control C will kill the ping. And you'll often use ping during your Linux installations, especially command line installations like archlinux, Gentoo, things like that. You'll ping a popular website like Google just to see if your Ethernet is working or not. Sometimes you want to download the contents of a file on the internet, and you can use wget for that. For example, if I wanted to download the contents of a particular web page, I'll download the contents of distro.tube/index.html. If I do that, it just downloaded that. If I do an ls, there is index.html. If I catted that just to verify, yeah, there is the actual HTML and the contents of my home page. Another command I could use instead of wget to download a file from the internet would be the curl command. For example, I could curl https://distro.tube/index.html, and then I could space -- output and specify a file name. Let's do this one, index2.html. And you can see it downloaded, and ls, and now I have index2.html. If I cat index2.html, just to verify, yeah, that the download did work. Let's talk about numbers. So let's start with the sequence command. If I sequence 50, it's going to give me 1 through 50 incrementally. Now, if I wanted to, I could take sequence 50 and I could get it shuffled up randomly. So I could pipe that through the shuff command for shuffle. And I get 1 through 50, except they've been shuffled up, right? They're all out of order. Another useful command would be the random command. Or the random, actually it's a shell variable. So if I echo $random all caps, I'm get a random number. If I up arrow, I get another random number. So sometimes you want some kind of random number generated for you, maybe in your scripting or your programming. So echo $random is a really easy way to get that random number. Let's talk about the test command. Test basically tests if a file or a directory exists on the system or not. So if I do test-f for file, I'm in that test directory. Remember, there's a file in here called file1. Well, let's test for it. Test-f file1. If I hit enter, nothing happens because really what I want to do is test-f file1 and means if that previous command actually succeeded without error, then I want you to do something. So let's echo the word true. And then I'm going to do 2 pipes together. So and is essentially and, a Boolean and. Pipe is the Boolean or, meaning, so if it's not true, then please echo false. And I should have ran that command without that colon at the end. I fat-fingered that. So file 1 does exist, but does file 2 exist? I know it doesn't, but let's run it just to verify that that command does work. And there's ls, by the way, to remind us what is in that test directory. So I'm going to up arrow. So now I'm going to do test-d to test if a directory named file2 exists. And of course, there's no subdirectories in this directory. So test-f for file, test-d to test if a directory exists. Let's talk about the xargs command, which is one of the most powerful commands we'll talk about today. So you're going to take some kind of source information, or maybe it's a command that produces some output, and then you pipe that into xargs space command, and you pass on another command. So basically, xargs is going to take whatever output came from the source or the previous command, and then it's going to pass that along as parameters for this second command. Let me show you an easy example here. So if I echo 1, 2, 3, and then I pipe this into xargs space touch, what's going to happen is touch is going to run touch and then 1, 2, 3. It would basically be the command touch 1, 2, 3. And if I do it ls, you can see now I have files named 1, 2, and 3 inside this test directory. Now, if I up arrow a couple of times and get back to echo 1, 2, 3, what if instead of xargs touch, now I do xargs rm for remove? Let's do a ls after running that, and you can see 1, 2, and 3 have now been removed. Let's talk about some commands you will sometimes see folks that are installing Linux distributions on camera, such as myself, will often run commands like lsblk for list block. What the list block command does, it lists all your block devices, and essentially what you're really looking for are your physical drives. You can see I've got 6 drives in this machine, actually 1, 2, 3, 4, 5 drives, 4 SSDs currently connected, as well as an NVMe drive. And you can see I can get the numbers. And the reason you'll run lsblk is because a lot of times you need the partition name. For example, which partition is mounted to what directory, especially when you're creating file systems for a Linux install. You want to make sure, for example, that you're formatting the right drive. lsblk will get you that information. Similar to lsblk, you could also use df. df is a command that also will give you your block devices as well as your loopback devices as well. And along similar lines is the du command for disk used or disk usage. Let me cd into the home directory. If I do a du in my home directory, it's going to tell me the size of these directories in my home directory, recursively, and it's going to be gigantic because my home directory, of course, is going to have thousands of subdirectories and subdirectories in those subdirectories, yada, yada, yada. Let's do it. du-a for all files and directories, h for human readable numbers, and let's do this in the test directory because there's so little in it. Now we get easy to read output here, and you can see all the files and the directories in the test directory, and you can see their byte sizes. Two nifty commands to know are the date command to get the current date, and the cal command to get a quick little calendar, so it's the calendar for the month you're currently in. A lot of times, though, you want a calendar with 3 months. You want this month and the one previous and the one next month as well. Well, you could do cal-3 to get your 3-month calendar displayed. Let's talk about a calculator. BC for basic calculator, bash calculator. I'm not sure what it stands for, but now you get a new prompt. If I do something like 5 divided by 3, for example, of course, that's going to be 1 with a remainder of 2. If we want to get the remainder, I could do 5 modulus 3. Let's go ahead and see what the remainder is. And of course, we already know it's going to be 2. 2 times 2, of course, is 4. Let me Control-C to get out of the basic calculator. And I could also do something like echo 6 divided by 2. And then, again, with the magic of pipes, pipe that into BC, and I could get the answer just displayed right here as output without ever having to go into the basic calculator prompt. Now let me copy a file over to the test directory. I'm in my home directory. I'm going to copy my .bashrc file over to test/ I'll call it bashrc. Now let me go ahead and cd over to the test directory. If I do a ls-la, you can see there is this bashrc, the new one, the copied version here in the test directory. Now this is a big file. What if I wanted to split it up? I could do split-n for number of splits. I want to split this into 5 chunks. So take, like 20% of the file. Every 20%, split it up. And of course we have to specify what file we're splitting. Now if I do an ls, you can see XAA, XAB, XAC, XAD, XAE. So it split it into those 5 chunks. If I do a cat on XAA, you can see that it ends right here, right? It just took the first, 20% of my bashrc. So how do you get these back into one file? So after you split, if you want to put these back into a file again, you use the cat command. Cat, even though people use cat 99.9% of the time, they use cat to read a file. That's all you want to do with cat. Cat actually stands for concatenate. That's what it was originally designed to do. It was to concatenate, meaning put back together these split files. So I could cat x asterisk for wildcard symbol, meaning any file that begins with x, I don't care what comes after the x. And then what I'm going to do is I'm going to redirect that into a new bashrc. I could name that anything, but now we've created this file, new bashrc, and if I vim the new bashrc, it is actually my bashrc all put back together again. Yeah, it looks exactly the way it should look. Now let's clean up this test directory. I'm going to remove every file that begins with x, so x asterisk, and I'll do an ls, so all of those x files are gone. Let me cd back into the home directory, clear the screen. The last command I want to talk about briefly is the time command. So what the time command does is you do time and then another command, and time will tell you the number of seconds it took for that command to run, or number of milliseconds for most commands, because most commands are very quick. For example, if I run tree on root, the tree command gives me the entire directory hierarchy on my system in that directory, in the root file system. This is going to take a long time, because there's probably tens of thousands of directories on the system. Let me Control-C to kill that process. I'm going to run a time on tree on root, and it's going to run, but at the end, it's going to also give us the number of seconds. And you can see it finished, and it gives us the time, and you can see the real time here was actually 28.3 seconds user time, and then the system time as well. You get 3 different time values. So there you have it, learning the Linux terminal in 30 minutes. That was a whirlwind tour. Now, most of the commands, practically all of the commands that I displayed on video, I've done dedicated videos going in much more detail about the individual commands. So check my command line playlist on YouTube. Now, before I go, I need to thank a few special people. I need to thank the producers of this episode: Gabe, James, Maxim, Matt, Mimit, Mitchell, Paul, Royal West, Armor Dragon, Bash Potato, Chuck, Commander Angry, George, Lee, Methos, Nate, Jan, Paul, Peace, Austin, Vodor, Polydate, Realities for Less, Red Prophet, Roland Tools, Devler, and Willie. These guys, they're my highest tier patrons over on Patreon. Without these guys, this Learn the Terminal in 30 Minutes video wouldn't have been possible. The show's also brought to you by each and every one of these fine ladies and gentlemen as well. All these names you're seeing on the screen right now, these are all my supporters over on Patreon. I don't have any corporate sponsors. I'm sponsored by you guys, the community. If you want to see more videos about Linux and free and open source software, subscribe to DistroTube over on Patreon. All right, guys. Peace. Oh, I forgot to talk about the calsay command.